Okay, rationalising the denominator. So, as an example, we can express root 80 plus 30 over root 5 in the form c root 5. So rationalising the denominator, if you think about what this means, a rational number is a fraction with integer numerator and denominator. So something like 12 over 71 is a rational number. The rational numbers include the integers as well, but they don't include any irrational numbers like pi and root 2, etc. They're called, irrational numbers. So, rationalising the denominator means getting the square root off of the bottom of your fractions. Your calculator will rationalise the denominator for you, but it's a technique that you need to know. And obviously, if there's letters on the denominator and you need to use an algebraic technique, then you're going to get stuck if you're not sure what you're doing. So please don't just rely on your calculator. So practice a few without a calculator, please. So I'm just going to break this into two parts. So root 80, if I want to get this in the form c root 5, I need to simplify root 80 down. And 80 is the square root of 16 times 5. Root 16 is 4. And that's root 80 kind of simplified into, the lowest number in a square root. So simplified right down. And then 30 over root 5. To get this root 5 off the bottom of here and to turn this into a rational number, the trick is to multiply top and bottom of the fraction by root 5. So the top becomes 30 times root 5, and underneath we've got root 5 times root 5, which is 5. And then simplifying this down, 30 over 5 is 6. So this is equal to 6 root 5. So going back to the original problem, root 80 plus 30 over root 5 is equal to 4 lots of root 5 plus 6 lots of root 5, which is equal to 10 root 5. So if you've just got a square root part, you can just multiply top and bottom by the root, and that will put an integer on the denominator. Just making this a little bit more complicated. Just realised I need to wipe my board. So if instead we have something like 4 plus root 5 over 3 plus root 5, then to rationalise the denominator now, I can't just times top and bottom by root 5 because we'll end up with 3 root 5 plus 5, so you'll still have a square root underneath. So instead we use difference of 2 squares. So I'm going to multiply top and bottom by 3 minus root 5. So the top becomes 4 plus root 5 times 3 minus root 5. And underneath 3 plus root 5, 3 minus root 5. So this is a difference of 2 squares, factorisation. So x squared minus y squared is equal to x plus y, x minus y. So when we multiply this out, the top I've got 12 minus 4 root 5 plus 3 root 5 minus 5. It's root 5 times minus root 5. And then underneath, I've got 3 times 3, which is 9, minus 3 root 5 plus 3 root 5. So they cancel each other out. And then root 5 times minus root 5 is minus 5. So the top of this becomes 12 minus 5, which is 7, minus 4 plus 4 root 5 plus 3 root 5 is minus 1. What's the root 5? So minus root 5 over 4. So you could leave it like that. I would normally leave them like that, but you could also divide that through by 4 and write that as 7 over 4 minus a quarter root 5 if you wanted to, but this generally is fine. So I'll just do one more. Say you've got 7 over 2 minus root 3, and I want to rationalise the denominator. Then I need to create difference of 2 squares underneath. So I'm going to times top and bottom by 2 plus root 3. Like so. And then the top becomes 14 plus 7 root 3. And underneath, I've got 2 times 2 is 4, plus 2 root 3, minus 2 root 3, they cancel each other out, minus 3, root 3 times minus root 3, minus 3, 4 minus 3 is 1, and so this one just goes down to 14 plus 7 root 3. So if you could do page 23, question 3, question 9, parts 1 and 3, question 10, parts 1 and 3, and question 14, which is some work on that.